Hey team, it's Mr. Z, and today we're going to continue in lesson 4 and build a cubic function out of multiple different functions. Let's go ahead and dive on in. So basically, we're going to be using the key characteristics of individual functions that build a cubic, revealing properties of the polynomial. So in part A, it wants me to choose a set of functions where 2 of them have imaginary zeros and 1 of them has a real zero. So for example, let's start out with the one it's a little more easier to understand. A real zero. Well, a real zero is 1, 0. I'm going to go ahead and choose the line y equals x has 1x intercept. It is real. It exists. Then we're going to go ahead and then we're going to pick 2 imaginary zeros. Now this is going to be fun. We're going to go ahead and pick something where it has no x-intercepts. We want something with 2 answers. They are not going to be on the x-intercept. They are going to be transformed. If I look at a graph, a quadratic typically crosses the x-axis twice. But if I use a transformation and move it up or down, what happens is that it no longer crosses the x-axis. The answers to degree 2 are imaginary. So I need to pick something with a transformation going up specifically. So I'm going to choose p of x when y, or p of x, is equal to x squared plus 1. X squared plus 1 is the graph x squared moved up 1 unit. So okay, now the idea is that we're going to be having to build a cubic, the product, by multiplying. So look at your x-intercepts. Over on the left side, I see that on 0, the p of x is a positive value. To the left, f of x is a negative value. So that means the product is going to be negative. Then, on the right side, they're both positive. F of x is positive, going to result in a positive product. So what's essentially going to happen is that our graph is going to go from being negative to being positive. Bada bing, bada boom. Now, this is something we would do in class. We would compare each other's. But basically, the idea is that it is a cubic. It is 3 parts. The big part is just to understand that p of x normally has 2 solutions, but the transformation up causes the function to not have an x-intercept. Okay, this next one, I need to figure out something where we have the y-intercept of 0, negative 1, And I also need it to be a cubic still. I still need it to be a cubic. So a y-intercept of 0, 1. Well, let me pick something with a y-intercept of -1. I see that, and let me be consistent with my colors. I see that, hey, the only one that is in standard form is h of x is equal to x minus 1. This is in standard form, meaning that the y-intercept is -1. So it's going to be -1, up 1. Okay. Now I need to multiply it by something, but the idea is that I want it to stay a -1. So basically, whatever I need to multiply by, I need to multiply by a cubic, but the key is that I want the end to be negative. So I'm going to go ahead and choose p of x for the specific property, or we'll say g of x. X plus 1. This would look like this. Okay. Now this is still not going to be a cubic. I need 3 things to be multiplying together. So my next guy, I'm going to just multiply it by f of x is equal to x. Okay. So we know the similarities. All the x-intercepts carry over in the product. When I look at them, I am looking at my graph. I have an x-intercept at -1. I have a 0 and a +1. Okay, let's look at behavior. To the left of -1, to the left of -1. So I'm looking at over here. I see that the red line is negative, the purple line is negative, and the blue line is negative. In between -1 and 0, I see the same behavior. However, here, the red line is positive, negative, negative. Analyzing the region between 0 and 1, I see there's a slight change. The red line is positive, the purple line is positive, and the blue line is negative. Finally, looking at after 1, I can see that the red line is positive. It is above the x-axis, positive. And then this is where the blue line becomes a positive. Okay, to get my final answer, I need to multiply these together. A negative times a negative times a negative is a negative. A positive times a negative is a negative, but then turns to a positive. Negative and positive. So I know the similarity is that the x-intercepts stay the same, and the graph is going to go from being a negative to a positive, back to being a negative to being a positive. Notice again, it's a cubic. All right, part C. 0 when x is equal to 1. I need it to have a multiplicity of 3. So I need a 0 to be at when x is equal to 1. This is where I want all my answers to be. Well, what produces a 0 with x equals 1? If you want to think about it, well, x minus 1 would be a 0 of 1. So picking the function that has that is going to go ahead and have me point to h of x, which is going to be x minus 1. So here we go. I'm going to graph this guy. It's going to be, I know I have that there. I know I have my y-intercept at -1 because this is in standard form. And it's going to continue. Okay, now I need this to have a multiplicity of 3. I'm going to just multiply it by the same line 3 times. I'm going to have h of x, and then I'm going to have another h of x. So all of these lines are going to be the same. So when I'm looking at the behavior, really I just look at 1, and they're all going to be the same. So here they're going to be positive, positive, and positive. To the left of 1, they are all going to be negative. The reason I have to go through it, I'm looking at the same line. But when I multiply this line times itself 3 times, it's going to be a negative and a positive. It's going to have the same x-intercept. And the end behavior is going to look something like this. It's going to go from being a negative to being a positive.